In this video, we are discussing probabilistic schedule in a way to address uncertainty existing in deterministic schedule. Probabilistic schedule is based on realization that project duration is not a fixed value, but a value determined from the probability distribution. Probabilistic scheduling gives a realistic view of the project plan, helping project managers predict the uncertainty and its effect on the plan. The probabilistic scheduling we are discussing is based on PERT, standing for Program Evaluation and Review Technique. Before we rush to discussing Python algorithm, I would like to make brief high level of probabilistic scheduling basics in terms of PERT. PERT adopts three activity duration estimates to address uncertainty existing in deterministic nature of activity duration. The project duration is estimated using the critical path method, CPM, with activities mean duration. The probability that the project can be completed within the expected project duration is 50%. And the probability distribution is normal in PERT probabilistic scheduling. Normal distribution is explained with 689599.7 rule. Once again, keep in mind that the probability that the project can be completed within the mean project duration calculated by CPM is 50%.
Excel is front-end package containing three activity duration data as input, and incorporating Python program result including probability distribution chart into Excel sheet. The probabilistic schedule is based on Python as the back-end language. The remaining video is dedicated to Python program, but with high-level details only. P50 schedule is produced by means of critical path method built in the class basic CPA. This can be implemented by inheriting the basic CPA class in the basic CPM module. Only the difference is activity period for critical path analysis. P50 schedule is based on activity mean period calculated according to PERT. For this purpose, the project period function for P50 schedule is developed newly to override that for basic CPM. Probability distribution is based on normal distribution with ±3 standard deviations. This allows us to predict completion probability percentage by the desired completion date. Separately, allows us to predict complete date to achieve the expected completion probability percentage. The function named PERT_stats is devised to calculate standard deviation and probability schedule range based on ±3 standard deviations. The input is made in the Tkinter form, encapsulated in the function named create form. The data is collected using the function named getData. Once OK button is enabled and pressed, a function named create PERT chart is called. As the first step, get data as entered and selected in the form. In the next step, computes distribution data, density distribution, and cumulative distribution referring to expected project duration and standard deviation calculated in critical path analysis. Predicted distribution data is produced based on the data gotten from the form. Finally, create a distribution chart. The function named distribution is devised to calculate density distribution and cumulative distribution of normal distribution within ±3 standard deviations from P50 project completion date. In addition, predicted completion percentage and predicted completion date are calculated. The prediction is based on input of desired completion percentage or desired completion date. The function named chart Excel is coded to generate an Excel chart using XLWings library. The chart is unlinked chart without referring to data on Excel sheet but referring to the distribution data calculated earlier. The chart is comprised of 3 graphs, a density distribution line graph, a cumulative distribution line graph, and a cumulative distribution column graph. By now, we have discussed significance of probabilistic scheduling, probabilistic scheduling basics, critical path analysis to generate P50 schedule, probability distribution, prediction of project completion percentage by certain project date, prediction of project completion date to achieve certain completion percentage, Tkinter form to define desired completion percentage or completion date. Present the probability distribution using Excel chart on the Excel worksheet. Create the unlinked chart for probability distribution and prediction. Thanks for watching.